What is the acceleration due to gravity g on Saturn? Consider a planet. Let's say this is Earth, and a person is standing on the Earth. Okay, so this is the person standing. Mass of the planet, let's use capital M. Mass of the person, let's use lowercase m. Distance between center of the planet to the center of the person is a little bit more than the radius of the planet r, the height of the person, let's say h, and the radius of the planet, let's say r, it is r plus h. R is big enough compared to the person's height. The distance d is about r. Now we are going to write universal gravitational force. It is Fg is the constant, universal gravitation constant g, multiplied by the ratio, first distance square, which we found here, d, which is r, and the mass of the planet times mass of the person, m. If this is calculated for Earth, that's going to give us m times g. This is about 9.8 meter per second square, depending on the location and the elevation. So this m, and what we see in this equation, lowercase m, and what we see g as g, lowercase g, is typically the remaining part of the universal law. So this remaining part, universal constant big G times the mass of the planet over distance square, is actually calculated for our planet as lowercase g, 9.8 meter per second square. That's the acceleration due to gravity. Now we are ready to write g, lowercase g, in terms of big G and mass of Earth, because we are writing it for Earth, divided by distance square, which is r Earth square. That's for Earth, g Earth. How about for Saturn? Now we need important information for Saturn. Let's do a Google search. Mass of Saturn. Mass of Saturn is 5.683 times 10 to the 26 kilogram. Now we need to compare this with the mass of Earth. Mass of Earth. Mass of Earth. Three times 10 to the 24 kilogram. Then we can write mass of Saturn in terms of mass of Earth. To do that, we need to multiply this a ratio which is 1, like 1 over 1. In this case, that's going to be m Earth here, and divided by 5.973 times 10 to the 24 kilogram. Kilogram will cancel, and the mass of Saturn will be found in terms of mass of Earth. So we need a calculator for that. Let's grab a calculator. 5.683 over 5.973. That gives us 0.95. I'm going to use 4 significant figures. So 0.9514. 9514. times 10 to the 26 minus, there was a 24 here, 24 mass of Earth. So that is 26 minus 24 is 2, 10 to the 2 is 100. This number, value times 100, 95.14 mass of Earth. To be more precise, 9514, it's also given here, 9516 mass of Earth. So either 16 or 14, that's depending on rounding you can use. That's the relation between mass of Saturn and mass of Earth. Now how about the radius? RE and RS. Radius of Earth. Six point 378 times 10 to the 3 meter. How about radius of Saturn? Information, radius of Saturn 5.823 times 10 to the 4 meter. Now I need to again do the conversion, multiply this by a ratio 1 at 1 over 1. In this case it's going to be a radius of Earth over 6.378 times 10 to the 3 meter. Again meter will cancel each other, and then I will find the radius of Saturn in terms of radius of Earth. 823 divided by 6.378. So that gives us 0.91298. So I'm going to round it 9130. 0.9130 times 10 to the 4 minus 3 radius of Earth. That's about 4 minus 1 is 1, so that means 9.130 radius of Earth. Now we have the relation between Earth's mass and Earth's radius of Saturn. These are the information using, I will rewrite GE. G Saturn is gravitational constant G, and I need to write mass of Saturn over radius of Saturn square. To compare with the Earth's acceleration due to gravity, I need to use these information. Mass of Saturn is we found to be 95.14 mass of Earth. The unit here is mass Earth over 9.130 RE parenthesis square equal 95.14 over 9.130 square multiplied by the remaining terms G, M, E, and RE square. G, M, E over RE square. Using a calculator, 95.14 over 9.130 square is about 1.141, and this term has a name that we found above as GE, acceleration due to gravity of Earth, GE. So G Saturn is 1.141 times the acceleration gravity of Earth G. We can numerically calculate this because we know acceleration due to gravity on Earth G on Saturn surface is about, let's say, 1.14 9.80 meter per second square. This is going to be an approximation. So that gives us G Saturn about 1.14 times 9.8, about 11.2 meter per second square. What's the acceleration due to gravity G on Saturn? It is 1.141 times G Earth G, and or 11.2 meter per second square.